Wow, the weather sure has been acting crazy lately. In order to solve this global climate change problem, we have to reduce or eliminate our use of fossil fuels, a non-renewable source of energy derived from ancient organisms where intense pressure over millions of years turns these organisms into hydrocarbons that provide an easy source of energy, but release lots of trapped greenhouse gas when used, warming the earth. This is where biofuels come into the picture. Derived from organic materials such as corn or sugarcane, biofuels act as a renewable source of energy that can easily replace liquid fuels such as gasoline. Biofuels offer us plenty of benefits, including the reduction of our carbon footprint and improving the economy by reducing our dependence on imported oil and strengthening the agricultural industry. Currently, we have two main types of biofuel, ethanol and biodiesel, and in the USA, we devote 40% of our corn yield to ethanol production. In order to create ethanol, we enlist the help of yeast to ferment plant sugars. In fermentation, yeast uses a series of enzymes, amylase, invertase, and zymase to turn plant matter into ethanol. Amylase breaks down starch, a complex carb, into disaccharides, such as sucrose. Invertase enzymes break these disaccharides down into monosaccharides, such as glucose, a simple carb. Now the zymase breaks the glucose down into ethanol, carbon dioxide, and water, while also forming ATP by attaching phosphorus groups to ADP in the process. Simply put, the yeast breaks plant sugar down into ethanol, carbon dioxide, water, and energy. Biodiesel, on the other hand, uses a process known as transesterification to turn plant oil and animal fat into biodiesel. By mixing fatty acids, alcohol, and a catalyst, the ensuing reaction forms a mixture of fatty esters and glycogen. Methanol is a good alcohol, and for the catalyst, we use a strong base or acid. Sodium and potassium methanolate are great catalysts. The formed fatty esters act as the building blocks of biodiesel, and the glycogen can be used in the cosmetics industry. It is important to note that production and use of biofuels does not decrease or increase the amount of carbon in the atmosphere. Instead, biofuels are part of a fragile cycle that maintains the current amount of carbon in the environment. For example, growing corn absorbs carbon, the corn makes ethanol, and when ethanol burns, it releases carbon back into the environment. It's kind of like a badly built Ferris wheel. So how do we improve biofuels? Well, first we throw corn into the trash and turn towards sugarcane as the major food crop. Since sugarcane contains sucrose, it skips a few steps in the fermentation process, and as a result is 7 times more efficient than corn. Algae also shows a ton more potential than both feedstocks. Algae has a high lipid content, which means it can more efficiently produce energy, and algae can grow in a variety of water sources. Conveniently, algae as a main foodstock will free up a ton of land for agricultural use, putting less stress on our food supply. So if we can avoid fossil fuels and biofuel production, regulate land use, and turn to different feedstocks, biofuel can become a great source of self-sustaining renewable energy, and we can keep that Ferris wheel spinning smoothly.